Hello guys, this is just a short little review of the type of problems you should be seeing on the Interim 3 tests. So, for this first set of group of problems, it's asking you what is the greatest common factor, and then what does it look like when you actually factor it. So when we look for a factor for a problem like this, we're looking at what number and what variable can we divide out of this. So into each one of the numbers, the largest number we can divide is 5. And then if we think about it, this is 5x's being multiplied together, this is 3x's being multiplied together, and this is 2x's being multiplied together. So each one has at least 2x's being multiplied together. And so then the factored form would look like 5x squared times 3x cubed minus 2x plus 4. In the second one, each one of the numbers is divisible by 3. They each have at least 3 m's being multiplied together, and they each have at least 2 n's being multiplied together. And so my fully factored form is 3m cubed n squared times 13. I'm sorry, and that 13 looks like a B, so let me fix that. Smartboard. 13 m to the 4th minus 8 n squared plus 1. Because remember, any number divided by itself is 1. And for the last one here, it would be 4x squared y squared, which would then factor as 4x squared y squared times 4x squared plus 3y minus 2y squared. And so really at this point we need to make sure we understand how to do greatest common factor. If you haven't, you might want to review IXL AA2. Alright, so factoring completely for this one is whenever there is no number in front of the x squared, or a is 1, then we're looking for two numbers that multiply together to give me 6. Sorry, let me restart that. I misspoke. We're looking together for two numbers that multiply together to give us 5 that add up to 6. And those two numbers are 5 and 1. So this will factor as the quantity x plus 5 times the quantity x plus 1. If you were to multiply this all out, expand it, FOIL, double distribute, whatever term your teacher uses, it would take you back to this. If you're still struggling with that, the relevant IXL is AA4. Here, there is a number in front, so we're going to have to do AC, which is multiply A, which is 12, times C, which is 2, and we'll get 24. And so I need two numbers that multiply together to give me 24, but that add up to B, which is negative 11. And those two numbers are negative 3 and negative 8. So what we're going to do is we're going to take 12x squared, but then we're going to split the negative 11 into negative 3x and negative 8x. And just as a tip, it's just makes it a little bit easier if you separate them with a plus. You could write 13x minus, but it just makes life a little bit easier if you put the plus in there, because when the next step is to group the first two and the last two terms and find the greatest common factor. So for the quantity 12x squared minus 3x, the greatest common factor is 3x. Then I'll leave the factored out, 4x minus 1. Here in the second one, because there was two negatives, when we split, we're going to factor out not the greatest common factor is 2, but we're going to factor out a negative 2 so that the second one also factors out as 4x minus 1. Because if this and this are the same, then that's a common factor, and the other factor is 3x minus 2. And if you're struggling with that, the relevant IXL is AA5. And here are just two more of the same type of problems, right? One where A is 1, so we're looking for two numbers that multiply together to give you 12 and add up to 8. And if you're struggling, write down the factor pairs, like 1 and 12 is 12, 2 and 6 is 12, and 3 and 4 is 12. And then we're like, okay, well, which one of those adds up to 8? And so this will be x plus 2 times x plus 6. And here, this, once again, I have a number out front, so it'll be a times c is negative 15. And so the two numbers that multiply together to give me negative 15 are negative 1 and 15. And so we're going to split these. And I also gave the tip, if you're going to, when you do the split, and then one's positive and one's negative, put the negative one first. It just makes life a little bit easier when you're factoring. Greatest common factor in the first one is x, and that gives me 3x minus 1. Greatest common factor in the second one is 5, which gives me 3x minus 1. So this will factor as x plus 5 times 3x minus 1. So those are the factoring. If you have any questions, you can go over those IXLs we talked about. I wanted to show one more special type of factoring, and that is the difference of squares. And the difference of squares is what happens if we multiply this out, where the numbers are the same, but they have opposite signs. So what happens when we multiply that out? So this will be x plus 4 times x minus 4. And that'll give me x squared minus 4x plus 4x minus 16. And when we combine the like terms in the middle, they cancel, and we're left with x squared minus 16. So if this turns into this, then by the same token, this can be factored back to that. And so what you're looking for is a difference of squares. Whenever we see something that is a binomial, or two terms, that is a difference, then it can be factored. So like here, this is a square, and this is a square. Well, what's the square root of x? Is x. And the square root of 9 is 3. And then one will be plus and one will be minus. Now, one of the ways they get you is they hide the difference of squares. And so always be on the lookout for a greatest common factor. And then what's left over on the inside is a difference of squares. So that's x plus 5 times x minus 5. Just want to make sure we had seen that before the test. All right, so here when they say quotient, there's two different ways to do these type of problems. If you have a polynomial divided by a polynomial, or multiple terms, then you want to factor the numerator. And so now this problem is exactly like this problem here, where what are two numbers, so the numerator, what are two numbers that multiply together to give you negative 12 that add up to negative 1, and that's so that you would get the top would be x minus 4 and x plus 3. But the bottom of the fraction is still x plus 3. And now because we have two numbers in the top being multiplied, we can cancel, and our answer is x minus 4. Here's the same type of problem, is this will be factor the top, and that'll be x plus 6 times x plus 1 over x plus 1. And the x plus 1's cancel, and I'll get x plus 6. If you have, let me just give you another type of problem that we might see. And I'm just going to write this out. It's not pre-prepared. If I had 3x cubed plus 2x squared, actually let me change that to 6x squared plus 9x all over 3x, then the technique here in the denominator, this is not a polynomial, this is a monomial or a single term. And so if we see it like that, then what you want to do is you can rewrite it as 3 separate fractions. And then I have a monomial divided by a monomial, and I can use my monomial rules to simplify each term like that. So that's the dividing. Next up, we have the type of problems that make sure that you understand how to identify a zero. And here the zeros are -2 and 3. And also that we understand the relationship between zeros and factors. And it's not that they're opposites, because this isn't 2, this is x plus 2, but that when you transfer the idea of the 0 to a factor, the sign changes. And then it has to do with when you move something from one side of the equal sign to the other, its sign changes. And so the equation for that is just y equals the 2 factors multiplied together. And the same thing here on this one, right? The zeros are -6 and -2. So the factors are x plus 6 and x plus 2. So my equation is y equals the quantity x plus 6 times the quantity x plus 2. Right here for solving, there's 2 different ways I at least taught my class to solve, which is by factoring or by graphing. And if you solve by graphing, you can use Desmos, and then you can just identify the x-intercepts, like on this problem, are the solutions. But if you want to do it by factoring, and this will explain the relationship between factors and solutions, is I look for 2 numbers that multiply together to give me 6 that add up to 7, and we've already seen that's x plus 6 times x plus 1. So zero product property says if I have 2 numbers, which is this number and this number, multiplying together to give you 0, then one of the numbers has to be 0. And so either x plus 6 equals 0 or x plus 1 equals 0. Well, if I solve this, I get x equals -6, and here I get x equals -1. And there you can see the relationship between the factor and the solution. These would also be the zeros you got if you graphed it. Here, the key is that to use a zero product property, you have to set it equal to 0. So I'm going to add 9 to both sides. And I'll get x squared minus 6x plus 9 equals 0. So that's going to factor as x minus 3 times x minus 3 equals 0. And what you'll notice is these 2 factors are the same, so it can be written as x minus 3 squared equals 0. But then x minus 3 has to equal 0, in which case x equals 3. And lastly, we had simplifying roots. And this was asking, can this be simplified? So I think that got cut off. Can this be simplified? And if it was not simplified, write it in. So here for B, right, if we look at it, the factors in here are 3 and 2. Neither one of those are perfect square, or if we've done it the other way, you can't pair any of those. So this is simplified, as is this one. This one is simplified. But here, if I break this out, there's 2 ways to do this. I can either do this as the square root of, well, let's do this way. This is the square root of 14 and 9, I believe. Let me double check my math there. Yes. So that's 3 times the square root of 14. But if you've done it using the factor tree, this is 2 times 63, which is 3 times 21, which is 3 times 7. And so we have a pair of 3's, and that's what goes on the outside. But then these 2 numbers didn't find partners, so you have to multiply them back together on the inside. And it's the same thing here for D. This is 4 and 5, which is 2 and 2, and x, 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 and y, 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 y. So we find things that pair. And when we pair them, we write them once outside each. But I had 2 pair of x's, so that's x squared, and I had 2 pair of y's, so that's y squared. Then what didn't get partnered stays behind, and that's that. Now if you're struggling with this, this is EE2, I believe, EE1 and EE2 and IXL, and so that's where you can practice those more if you need to. So good luck on the test, and we'll see you next class. If you have any questions on any of this, ask your teacher. Thank you.